Okay, so we're going to take a look at inverses in real life applications. The big thing to know with inverses and word problems is you are not going to swap the letters. So in previous problems, when we were trying to find our inverses, we switched the x and y and we got y by itself. You cannot do that with word problems because these letters actually mean something. An x and y is just a variable. But in these cases, like for instance, 53 that you see up there, the V stands for something. It stands for speed. The L stands for length. I can't switch their positions because now it's messing up the entire problem and the application of it. So when you are asked to find an inverse of a word problem, you are simply just going to solve for the other variable. So usually one's going to be by itself, another one's going to have, all the mathematical stuff around it, and you will just have to do the work to get the other one alone. Okay. They could even specify exactly what letter. They may say, find the inverse of the function in terms of V. In that case, it means get the L by itself because you want V within the mathematical work. Okay. So in this problem here, again, we have V equals 1.34 square root of L. We want to get that L by itself so we can find the inverse. So in order to do that, first thing we want to do, get rid of that multiplication by dividing. I'm going to leave it in that fraction form. And then again, to undo a square root or any root, you're just going to raise it to that power. So a square root is a squared power that I would raise it to. And in this case, I have L equals V over 1.34. And that whole thing is squared. I can now use that to help me find a solution easier. So it says, what's the waterline length to achieve a maximum speed of 7.5 knots? Well, from here, I can just simply put in the 7.5 in for the V, because that's speed, and then put that in my calculator, and we get about 31.3 feet. Okay. Now, it doesn't mean I couldn't solve the problem where it was given. I could have put 7.5 in here and had 7.5 equaled 1.34 square root of L and solved for L. I could still solve the problem without finding the inverse, but this makes it a whole bunch easier. If I already know what the equation is for L, then no matter what they ask me, if they ask me to find the length or if they ask me to find the speed, I have an equation set up easily for me to utilize. Okay. So for number 54, same thing. They're going to give us an equation. So in this case, we have resistance in pounds is my R equals 3/8 the length in inches minus 5. All right, so if we have to find the inverse, we want to find the L, get that one by itself. We know we can add the 5 to both sides. And then to get rid of the 3/8, you're going to multiply by the fraction's reciprocal. Now it's up to you. You can distribute that 8/3 into it, or you could simply just leave it as 8 times that product. That might be easier for some people. And there's my L function. Now, if they ask us, what's the length, L, of a 19-pound resistance? Well, I can then use this equation really easily, put it in my calculator, and it comes out to 64 inches. Okay, and our last one, a very common one, talks about temperature. So a Celsius is the equation 5/9 times the function, or the Fahrenheit, minus 32. Okay, that's the Celsius equation. They want us to find the inverse and describe what it represents. Well, it's going to end up representing Fahrenheit degrees because we want to get the F by itself. So we're going to start by getting rid of the fraction. So I'm going to multiply both sides by 9/5. And I have to do that first because I can't move something inside parentheses. If you wanted to distribute, you could, but I can simply get rid of it right away by multiplying by its reciprocal. And now it's really easy. Just add the 32 to both sides. And now we have our Fahrenheit function. So Fahrenheit equals 9/5 Celsius plus 32. So part B is we'll find the temperatures at the start and the end of the race. Well, at the start of the race, it was 5 degrees Celsius. So we are simply plugging in 5 into my equation, and it's going to come out to 41 degrees Fahrenheit. At the end of the race, it was negative 10 degrees Celsius. So I'm going to do the same thing, put a negative 10 now into my function, and that is going to get me 14 degrees Fahrenheit. Okay, so that's the usage of it. Now part C, it says use a graphing calculator to graph the original and the inverse and find the temperature that is the same on both. So in order to graph it, I put it into Desmos. I then graphed each one of them. Now when I put them into Desmos, I did use Y and X. So now they were actually legit inverses. So here was my Celsius one, 5/9. 9/5 was my Fahrenheit one. Here's the two graphs. And if we're looking to see where they're the same, we're looking to see where they cross. And I had to zoom out a bit, but they do cross down here. And if I click on it, there they are, identical. Negative 40 degrees Celsius and negative 40 degrees Fahrenheit is where they do share. So that would be the answer to the solution for part C. The temperature that's the same is 40 degrees on both Celsius and Fahrenheit. Okay, so again, with your word problems, just remember, do not swap your letters, just solve for the other equation, or sorry, for the other variable in the equation.